Hi everyone, this is Dr. Mark Dennis, and welcome to our Week 2 live chat session yet again here for Finance 4501 Investments. The focus for this segment of our live chat sessions is final project tip number 2. This time we're diving deep into the Treynor measure, a powerful tool for evaluating portfolio performance. Let's get started. As a reminder, your final project will involve comparing and contrasting 4 key performance measures: the Sharpe ratio, Treynor measure, Jensen's alpha, and the Modigliani or M-squared measure. Each of these methods helps us evaluate how well a portfolio performed, considering different aspects of return and risk. You'll also be analyzing data from a set of hypothetical investment portfolios. In this session, we'll focus on breaking down the Treynor measure, a favorite in institutional settings. Conduct your analysis by producing a formal, detailed 3 to 5 page, at a minimum, essay, including incorporation of Excel spreadsheets and charts as needed, along with multiple APA sources and citations. Make sure your essay includes the following: definition and origin of each risk-adjusted portfolio measurement technique, portfolio measurement calculations for each portfolio, which means you'll do the Sharpe, Treynor, Jensen, and M2 measurement for all of the portfolios. Then you will rank each portfolio in order of preference for each measurement technique. Be sure to discuss why different portfolio measurements may lead to a different ranking. Demystifying the Treynor measure. Let's talk about the Treynor measure, sometimes referred to as the reward to volatility ratio. At its core, this performance metric tells us how much excess return a portfolio earns for each unit of risk it takes on. This is incredibly useful when we want to compare portfolios with different risk exposures. So what do we mean when we say excess return? This refers to the return earned beyond what you would expect to receive from a risk-free investment. While nothing is truly risk-free, U.S. Treasury bills are often used as a practical proxy in this context. The Treynor formula is actually quite straightforward. It involves only 3 primary components. First, there is the portfolio's return. This is the actual return generated by the investment portfolio. Next is the risk-free rate, typically the yield from short-term treasuries like the 3-month T-bill or treasury bill. And then there's beta, which measures the portfolio's sensitivity to market movements, also referred to as systematic risk. The result tells us how efficiently a portfolio is compensating investors for taking on market risk. The higher this ratio, the better the portfolio performed relative to that risk. We'll take a look at each of these components more closely in the next few slides to make sure you know exactly how to use them in your final project. Portfolio returns. Before you can use the Treynor formula, you'll need to calculate the expected return for each portfolio. This involves estimating the return of each individual asset in the portfolio, multiplying each by its weight in the portfolio, and then adding together all of those weighted values. This, of course, gives you the weighted average return of the entire portfolio. Let's consider a practical example. Suppose a portfolio consists of three assets. Asset A with an expected return of 10%, and it makes up 16.7% of the portfolio. Asset B has an expected return of 12%, and it makes up fully 1/3 or 33.3% of the portfolio, and the remaining 50% of the portfolio is represented by asset C with an expected return of 16%. Calculating the expected return of the portfolio is simply a matter of multiplying the expected return of each asset times its weight, as you see in the formula on the slide. This value becomes the numerator in the Treynor formula. Just be sure you're consistent in how you express the return as either a decimal or as a percentage. The risk-free rate represents the return on an investment with virtually zero risk. In practice, we use the interest rate on a 3-month U.S. Treasury bill as a proxy for the risk-free rate, especially for U.S.-based investors. You can find this data on sites like Barron's Market Data, which is referenced here. This figure goes into the Treynor numerator as the baseline return to beat. Now let's talk about beta, which is the third and final component of the Treynor formula. Beta measures systematic risk, the kind of risk you cannot diversify away. That's because it's tied to the overall market. A beta of 1 means your portfolio moves in lockstep with the market. Higher than 1, then it's more volatile than the market. What if it's less than 1? Then your portfolio is more conservative. Treynor focuses specifically on this type of risk, not total risk, making it a more refined measure when used on diversified portfolios. So here's the full formula in action. Treynor ratio equals the difference between portfolio return and the risk-free rate, with that result divided by beta. This gives you a measure of the excess return per unit of market risk. This is similar in spirit to the Sharpe ratio, but where Sharpe uses standard deviation, which includes both systematic and unsystematic risk, Treynor uses only beta. For well-diversified portfolios, these two ratios often lead to similar conclusions. But for fund of fund setups, Treynor can be more appropriate. This is especially true for institutional portfolios, like those managed by pensions, endowments, or foundations. These portfolios are typically managed by multiple fund managers, and their non-systematic risk, the stuff specific to individual holdings, is mostly diversified away. So using the Sharpe ratio, which includes that residual risk, will become less useful. This is where Treynor shines, because Treynor isolates systematic risk only, giving you a cleaner performance measure for large, diversified strategies. According to conventional financial theory, the higher the Treynor ratio, the better. Why is this? Because it means you're earning more return per unit of market risk, which is exactly what a rational investor wants. In other words, it's a sign that the portfolio is doing a good job of compensating you for the risk you've taken as an investor. For your final project, you will be calculating the Treynor ratio in Excel for several portfolios. For example, you might use this formula for portfolio A. The difference between B5 and B11, so B5 minus B11, and then take that result and divide that by D5, where B5 is the average return, B11 is the risk-free rate, and D5 is the beta of the accompanying portfolio. Be sure to clearly label your cells and double check for errors when using the spreadsheet approach. And of course, apply this process to all the portfolios in the assignment. This wraps up our overview of the Treynor measure and how it fits into your project. If you have questions, of course, don't hesitate to reach out, email, or give me a call. Good luck with the analysis. I look forward to seeing your work.